It is indeed possible to change over a 120/240 single-phase system to a 460 volts three-phase system. The existing system operates with 120 volts to neutral on all legs and 240 volts between any two phases, which confirms that it is a single-phase system. The required system is a 460 volts three-phase setup, which is distinctly a three-phase system. The conversion process entails several key steps. Firstly, installing a three-phase transformer is necessary. This transformer converts the existing single-phase power into the required three-phase power. Secondly, a three-phase panel needs to be installed. This panel will distribute the newly converted three-phase power to the intended 460 volts loads. Thirdly, the existing wiring and devices must be replaced. This replacement ensures that all components including wiring, breakers, switches, and outlets are compatible with the new three-phase power supply. The hood fan system requires 460 volts three-phase power. If the conversion is executed correctly and the system is wired appropriately, connecting the hood fan system to the new 460 volts three-phase panel should be feasible. Several important considerations need to be addressed during the planning and execution of such a conversion. Firstly, cost is a significant factor. Converting to three-phase power can be an expensive undertaking due to the equipment and labor involved. Secondly, feasibility needs to be assessed. The feasibility of the conversion depends on the existing electrical infrastructure, wiring, and panel capacity. A thorough evaluation is essential to determine if the current setup can support the proposed changes. Thirdly, professional expertise is indispensable. This conversion should be performed by a qualified electrician who has experience with three-phase systems. Lastly, safety must be prioritized. Three-phase systems can be dangerous, and proper precautions are required to ensure safe installation. Recommendations include firstly consulting with a qualified electrician to assess the feasibility of the conversion. Secondly, obtain additional specifications for the hood fan system, including current draw and motor specifications to ensure compatibility with the new three-phase system. Thirdly, determine if the existing wiring and electrical infrastructure can support the conversion, considering factors such as load capacity and wiring size. If the conversion is deemed feasible, proceed with the necessary steps to ensure a safe and compliant installation. Understanding the nuances of three-phase power is crucial for anyone working with such systems. A three-phase system delivers power using three alternating current signals. These signals are offset from each other by 120 electrical degrees. This configuration provides a more consistent and efficient power delivery compared to single-phase systems. In a three-phase system, you'll typically find different voltage configurations depending on the wiring arrangement. Common configurations include 208/120 volts, 480/277 volts, and 600/347 volts. In a 208/120 volt system, the voltage between any two phases is 208 volts, while the voltage from any phase to neutral is 120 volts. Similarly, in a 480/277 volt system, the phase-to-phase voltage is 480 volts, and the phase-to-neutral voltage is 277 volts. These voltage levels are crucial to understand when connecting equipment and ensuring proper operation. When dealing with three-phase systems, several key components play a critical role. Transformers are used to step up or step down voltage levels to match the requirements of the equipment being powered. Circuit breakers provide overcurrent protection to prevent damage to the wiring and equipment in case of a fault. Conductors or wires carry the electrical current from the source to the loads. Proper sizing of conductors is essential to prevent overheating and voltage drop. Grounding is a critical safety measure in three-phase systems. Grounding provides a low impedance path for fault current to flow back to the source, allowing the circuit breaker to trip and to energize the circuit. This helps to prevent electrical shock hazards. When installing or modifying a three-phase system, it's important to adhere to the National Electrical Code, or NEC. The NEC provides detailed guidelines for wiring methods, overcurrent protection, grounding, and other aspects of electrical installations. Following the NEC ensures a safe and compliant installation. Some common issues that can arise in three-phase systems include voltage imbalance, harmonic distortion, and phase loss. Voltage imbalance occurs when the voltages between the three phases are not equal. This can lead to overheating of motors and other equipment. Harmonic distortion is the presence of unwanted frequencies in the electrical system which can cause interference and damage to sensitive electronic equipment. Phase loss occurs when one of the three phases is lost, which can cause motors to stall and potentially burn out. Troubleshooting these issues requires specialized equipment and knowledge. It's important to use appropriate test instruments such as multimeters and power quality analyzers to diagnose and resolve problems in three-phase systems. Remember, working with three-phase systems can be dangerous, and it's essential to follow proper safety precautions. Always to energize circuits before working on them and use appropriate personal protective equipment such as gloves and safety glasses. If you're not comfortable working with three-phase systems, it's best to consult with a qualified electrician who has the necessary expertise and experience. Converting from single-phase to three-phase involves specific components and a systematic approach to ensure a safe and reliable electrical system. A key component in this conversion is the rotary phase converter or a static phase converter. Rotary phase converters are electromechanical devices that use a motor generator set to create a balanced three-phase output from a single-phase input. They are generally more efficient and can handle higher loads compared to static phase converters. Static phase converters use capacitors to simulate a third phase, allowing three-phase motors to run on a single-phase supply. However, they are typically less efficient and have limited starting torque capabilities. The selection of a phase converter depends on the load requirements and the specific application. When dealing with motor loads, it's crucial to consider the motor's horsepower rating and starting current requirements. Three-phase motors are generally more efficient and have higher starting torque compared to single-phase motors. However, converting to three-phase power allows you to take advantage of these benefits. The wiring of a three-phase system involves specific color coding to identify each phase. In North America, the standard color codes are black, red, and blue for the three phases, with white typically used for the neutral conductor and green for the grounding conductor. These color codes help to ensure proper wiring and prevent phase-to-phase faults. Overcurrent protection in a three-phase system is typically provided by three-pole circuit breakers or fuses. These devices are designed to protect the wiring and equipment from overloads and short circuits. Proper sizing of overcurrent protection is essential to ensure that the circuit breaker or fuse will trip before damage occurs. Grounding in a three-phase system is crucial for safety. The grounding system provides a low impedance path for fault current to flow back to the source, allowing the overcurrent protection to trip and to energize the circuit. This helps to prevent electrical shock hazards and minimize damage to equipment. Common grounding methods include equipment grounding and system grounding. Equipment grounding involves connecting all non-current carrying metal parts of the equipment to ground. System grounding involves grounding the neutral point of the transformer or generator. When working with three-phase power distribution, it's important to understand the different types of distribution systems. Common types include Y systems and delta systems. In a Y system, the neutral point of the transformer is grounded, providing a stable reference point for voltage. Y systems are commonly used for general-purpose power distribution. In a delta system, the neutral point is not grounded, and the voltage between phases is higher than the voltage to ground. Delta systems are often used for industrial applications where higher voltage levels are required. Balancing the load in a three-phase system is essential to ensure efficient operation and minimize voltage imbalance. An unbalanced load can cause excessive current to flow in one or more phases, leading to overheating and potential damage to equipment. Load balancing involves distributing the load evenly across the three phases. This can be achieved by carefully planning the connection of equipment to the electrical system. When troubleshooting three-phase systems, it's important to use appropriate test equipment and follow proper procedures. A multimeter can be used to measure voltage, current, and resistance. A phase rotation meter can be used to verify the correct phase sequence. An insulation resistance tester, also known as a megger, can be used to check the insulation of wires and equipment. Safety is paramount when working with three-phase systems. Always de-energize circuits before working on them, and use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. If you are not comfortable working with three-phase systems, it's best to consult with a qualified electrician. The NEC provides comprehensive guidelines for the installation and maintenance of three-phase electrical systems. These guidelines cover topics such as wiring methods, overcurrent protection, grounding, and equipment installation. Following the NEC helps to ensure a safe and compliant installation. In addition to the NEC, there may be local electrical codes and regulations that must be followed. It's important to check with the local authorities to ensure compliance with all applicable codes and regulations. Regular maintenance is essential to ensure the reliable operation of a three-phase electrical system. Maintenance tasks may include inspecting wiring and connections, tightening loose connections, cleaning equipment, and testing overcurrent protection devices. Keeping a detailed record of maintenance activities can help to identify potential problems early and prevent costly repairs. When planning a conversion from single-phase to three-phase, it's important to consider the future needs of the facility. Will there be additional equipment or loads added in the future? It's best to size the three-phase system to accommodate future growth. This will help to avoid the need for costly upgrades later on. Converting from single-phase to three-phase can provide numerous benefits, including increased efficiency, higher power capacity, and improved motor performance. However, it's important to carefully plan and execute the conversion to ensure a safe and reliable electrical system. Consulting with a qualified electrician is highly recommended. They can assess the feasibility of the conversion, design the system, and perform the installation in accordance with all applicable codes and regulations. When working with three-phase motors, it's important to understand the different types of motor starters. Motor starters are used to control the starting and stopping of three-phase motors. Common types of motor starters include across-the-line starters, reduced voltage starters, and variable frequency drives. Across-the-line starters apply full voltage to the motor terminals at startup. This is the simplest and most common type of motor starter. However, it can cause a large inrush of current, which can stress the electrical system. Reduced voltage starters reduce the voltage applied to the motor terminals at startup. This reduces the inrush current and minimizes stress on the electrical system. Common types of reduced voltage starters include auto-transformer starters, reactor starters, and part-winding starters. Variable frequency drives, also known as VFD, control the speed and torque of the motor by varying the frequency and voltage applied to the motor terminals. VFD offers several benefits, including energy savings, improved motor control, and reduced mechanical stress. When selecting a motor starter, it's important to consider the motor's horsepower rating, voltage, and starting current requirements. The motor starter should be sized appropriately to handle the motor's load. When installing a three-phase motor, it's important to ensure that the motor is properly grounded. The motor frame should be connected to the equipment grounding conductor. This helps to prevent electrical shock hazards. The direction of rotation of a three-phase motor can be changed by swapping any two of the three-phase leads. This reverses the phase sequence and causes the motor to rotate in the opposite direction. When connecting a three-phase motor, it's important to verify the correct phase sequence. This can be done using a phase rotation meter. If the phase sequence is incorrect, the motor may not start or it may rotate in the wrong direction. When troubleshooting three-phase motors, it's important to check the voltage, current, and resistance of the motor windings. A multimeter can be used to measure these parameters. Common problems with three-phase motors include winding shorts, open circuits, and ground faults. These problems can be identified by measuring the resistance between the motor windings and ground. Regular maintenance of three-phase motors can help to prevent costly repairs. Maintenance tasks may include lubricating bearings, cleaning windings, and inspecting for loose connections. Keeping a detailed record of maintenance activities can help to identify potential problems early and prevent breakdowns. When replacing a three-phase motor, it's important to select a motor with the same horsepower rating, voltage, and frame size. This will ensure that the motor is compatible with the existing equipment. Converting from single-phase to three-phase is a complex process that requires careful planning and execution. Consulting with a qualified electrician is highly recommended. They can assess the feasibility of the conversion, design the system, and perform the installation in accordance with all applicable codes and regulations.